First Spin. Welcome to First Spin, a show where I learn how to use the Parallax Propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts, Roy and Whisker.
She keeps us in the basement.
It's dark down here.
It puts the lotion on its skin. I have a question. Can I now say that I've had some prior programming experience?
A little bit.
I guess I
Yeah.
could. I guess I
You've
could
actually written some programs.
Huzzah! So
Nothing prior to
apologies for
doing
the
the show, though.
for the false advertisement there in my intro.
Well, the intro was based on before we started this podcast at all.
That is
right?
true. I guess that is true. So prior programming experience prior to First Spin.
Right.
I think
All
that's
right.
confusing. A lot of these shows are offset by a couple of weeks because we record them in groups, and so this was recorded before experience that she's already had.
Time
Yeah.
travel.
By the time you hear this, she's already doing advanced programming compared
Oh
to what she's
man,
done right now.
that's right. That's right. I'm ahead of the times.
Okay, so
You need a time machine to go back to when she knew this stuff.
We are just being silly. Let's focus on
can you
data
make
blocks.
a propeller with that?
I had a question.
What clock mode is that?
Focus.
What?
Focus. I had a question before to as to whether or not Spin could change the data block section
Right.
midstream, and
You can.
I was gonna drum roll.
The data blocks are, the data in the data blocks are accessible from Spin via the symbol labels that are optionally able to put in front of them, and then you can just assign to them or read from them. Typically, the usage is to just read from them, but you could store to them, but typically it's you store to variables in the var section, right? It's a little easier to work with those. But anyway, yeah, you can read and write.
Excellent. That sounds like a very
Part of the reason I didn't know that kind of thing right off the top of my head is because I usually use the DAT section to do assembly programming.
Sure.
And I put a whole bunch of assembly code in there and labels to values in there for my assembly code, and that's what I use it for. And it's just, I've never really considered using it to hold data that I would write to from Spin. Reading from, yeah, but writing to is kind of an odd usage for me. Somebody will probably mail in or message us saying, "Oh, but I do it this way all the time." But anyway.
Gotcha. So I think the way that this next segment, the categorical listing of Propeller Spin language, I think it pretty much just goes through everything that we've already gone through, kind of, or no?
There a little bit, but it sort of groups all the stuff together. That first page is just, shows all the different block designators, and then it also has like the clock setting stuff and whatnot. But once you get into the second page there, page 39 of this stuff, it starts actually talking about the groups of cog commands.
I see.
And we get into things like flow control, where you use your if and case stuff, and on the next page after that is the repeat command.
Okay.
So we probably should go through some of that stuff, since I'm sure you have some questions. I know you've used it a little bit in those few LED blinking programs that you've written and talked about on your blog and whatnot.
Right. So I've used CogNew, which spawns off a cog. And so, I mean, I'm pretty comfortable with that.
Right.
CogID, when would you use that?
Well, CogID tells you the ID of the current cog. So you could use it to figure out which cog you are running on with your current code. And then that information could then be used to do things like stop that cog if you want to stop the one you're currently running, or you could pass it to a piece of code in another cog, and it could do things like send you messages back with your ID. It's just a informational thing that you can use wherever you want.
Okay, so then when you stop your cog, does that in effect, quote unquote, erase its RAM?
Well, the cog itself will just stop executing. The
Okay.
next time you start it, it will wipe its memory and load it up with whatever
Oh,
is loaded. And when it's in low memory state, I assume that it goes into the memory is sort of undefined state, right?
I
It goes into
see.
power mode when you stop a cog. So
I see.
it just gets into an undefined state as far as the code is concerned. But as soon as you start a new cog, it loads it up with code.
I see.
Fills
So
up its
CogStop is actually a full stop. It's not like you're pausing it. And in order to
right.
pause it, you'd have to like wait count it or something like that.
Right. Yeah. If you
Okay.
want to pause a cog, you need to have that cog's code actually do something to pause itself using wait, like you said,
Gotcha.
or some other loop that wouldn't put it into low power state. It's up to you.
Okay. Now this
Mhm.
cog initialize or the CogInit, it says start or restart a cog by ID. So why
So CogInit is where you can. It's just an alternate form
of
of
CogNew?
doing CogNew that's a little more
Oh,
advanced. It allows you to start a specific cog ID number. Like you want to start cog ID 4 with a certain piece of code.
okay.
And it also could restart that cog. So if that cog's already running,
Mm-hmm.
CogInit can cause it to be restarted.
Okay.
You don't have to actually stop it and start it again. You can just use CogInit and just initialize it with the same code or new code. I've used this a few times where I've had like a single cog that I have some utility code running in, and I will call CogInit and pass it a function and let that function run, and it'll go off and do something. And then later on in my program, I'll just call CogInit with the same ID
Mm-hmm.
and just it blow away whatever was in there and start the new function,
Hmm.
right? Um, it's just a alternate way of doing things.
Gotcha. Okay.
And can be used for specific special needs.
Okay. Gotcha.
Mhm.
And then lock new.
So when you get to the lock new, lock return, lock clear, and lock set stuff,
Mm-hmm.
um, those are used for setting some flags that are in the hub space,
Mm-hmm.
which is, as you remember, is a shared resource.
Right.
And so when you create a lock,
Like for the locked bits?
right, that's the lock bit stuff that we talked about.
Okay.
So you would issue one of these commands, the lock and new,
Yeah.
to allocate a lock bit and say, okay, I'm going to use this lock bit for communicating with the other cogs. And then you would do, the lock clear and lock set and lock return is in your code. You would use those commands to work with that lock bit, and the other cogs would use it to start and stop themselves based on waiting for the lock to be free, right? So it allows you the two cogs communicating with each other, like we talked about many episodes ago, um, to stop each other from messing each other up by using the lock mechanism.
Right.
It's a fairly advanced, multi-processing mechanism, um, and it's something that I think that we need to wait to go into full detail on till we have an example we can walk you through
Okay.
later on.
And when you're designing things, I mean, obviously you're going to try to design them in such a way that you don't have to lock things.
Right.
You would only use these if you're stuck in a situation where you need to.
Right. And I've used this in a couple of my programs. It's pretty rare, but the one example I used it in was I had one cog sending messages to another cog through the hub memory, and the messages were longer than one long. I had to send 4 longs of data. So I would use the lock bit to say, okay, I'm going to load up those 4 longs now from the one cog, and then the other cog was constantly trying to read them, but it would use that lock bit to not read it when the other one was writing it, so that it wouldn't get it partway through.
So, like in the event, so I know a lot of people who work with propellers like to work with robots, right?
Right.
And so, say you're using something like the laser rangefinder, and I mean, I'd imagine there's quite a bit of data that it's sending to, like,
Well, it's really just giving you a distance back, a single number
oh,
most of the time.
But then,
I mean,
like, say that single number was used to execute a number of commands, right? So, like, if the bot sees there's something in its way, then it turns its wheels, this direction. It
yeah,
blinks a
well,
little light. Like, would those?
but you could still write all those into different cogs in such a way that you wouldn't really need a lock,
Mm,
because you would just have the distance being written by one cog by reading the laser rangefinder,
mm-hmm.
and then the other cogs just read the distance, and there's no need to lock around things like that when it's a single long value, because it's always right, because when it's a single long value, only one cog can read or write it at any given time.
Mm-hmm, mm-hmm.
So you'll never get an invalid data.
Gotcha.
Like I said, the main time you need it is if you're trying to communicate more than one long worth of stuff between multiple cogs.
Okay.
Um, and again, it's a more advanced concept that a lot of people never need to worry about or use.
Mm-hmm.
And you can typically come up with a way in your code to not need it.
Mm-hmm.
Um,
It's
but
just it's
it's a
interesting.
feature that's there to
Yeah.
allow for advanced users to use it, right?
Yeah.
Um,
Now, wait, one last question. Is it kind of like the interrupt system?
no, it's not really. I mean,
Kind of.
conceptually, it allows you to do some things that are similar to what an interrupt might do sometimes, but that's not really the right way to think about it. It's
Okay.
more of a protection mechanism where the cogs are cooperating with each other to not mess each other up,
Okay.
right? And they use the lock bits to do that.
Okay. Fair enough. We know weight count, weight peak,
So
PEQ.
let's just talk about the main three weights there: weight count, weight PEQ, and weight NE.
Okay.
And PEQ is wait for pin equal and wait for pin not equal.
Mm-hmm.
And it's pin or pins. And you give it the pin mask, which is, the ones and zeros saying which pins you care about.
Mm-hmm.
And the equals one is you pass in what you want the pins to equal. Like, what state do you want those pins, ones or zeros, to equal?
Mm-hmm.
And the not equal is the opposite, right? It's
So
waiting for the not equal that. So if you're using a single pin, right, you would say, wait PEQ for pin 16 to be a 1, right?
yeah.
That's how you would use it. Or wait for it to equal 0.
Oh.
It just
And that's how,
dawned on her.
Okay, so it's kind of like if a pin says its output. So it sees say it sees
typically
something
we
in
use
front of
these on
itself.
inputs. You would use these on inputs. So you would have, say you have pin 16 has a light sensor on it that will go high when the light's there and go low when the light's not there. You could use wait PEQ to wait for the pin to go high and then react.
Oh,
Yeah,
so like red light,
so
green light.
yeah.
Right.
So everyone out there who's
Uh,
confused on how you would do some of the things that you would uh, do on other platforms where they have interrupts, this right here is your answer. You can do the same kind of interrupt on a pin thing. This is the command you'd use to do it.
Yeah.
That's cool.
So what you'd do is you would do a CogNew of a function that had one of these wait PEQs in it, and in that cog, it would just sit over there waiting for the pin to go high. And as soon as it went high, then it would have code right after the wait PEQ that would do the appropriate response. Like if you shined a light on it, if it was supposed to beep, then it would play the sound that it was supposed to beep, right? And then it would wait for then you would do a similar wait PEQ to wait for the pin to go low again, right? So you move the light away, and then it'll go back up and wait for it to turn on, right? So you could do something like that. And you could do that. There's any number of combinations of things. You could have buttons hooked up to pins. You could have, all sorts of checks,
Sensors and such.
sensors, and all kinds of. It's basically just waiting for the pin to be in a specified state.
And let's
Right.
be clear, that's pin or pins. So you could
Right.
have like a set of 8 pins on there that have to be equal to this or have to be not equal to that. before it'll move past this statement.
So then, Whisker, for your Robo Jib project, would you use this so that, like, when you pressed, say, position 1, and 3 pins, the X, Y, and Z axes, for position 1 turned on 1, then with this formula, then once it had seen that those 3 specific pins had been turned on, then the camera would start moving to that position?
Yeah, I mean, that's sort of how you can do it. That's not how I'm going to do it, but yeah.
That is one mechanism you could use with it, yeah.
I see.
And another thing to specify, just so that people understand, whenever you use the wait commands, any one of these wait commands, most importantly the pin ones and the count one, while it's waiting for that state to occur, it's stopped on this command in the program and sits there waiting, and it actually puts the cog into a low power state.
Oh.
So that it's not consuming as much memory or as much power. And that's one of the things that you use the interrupt mechanism for on other processors, which we hinted at earlier. So that's what, like, you can have a cog sitting there waiting for a light, and it won't be running continuously. It'll just be sitting in the WAITPEQ or WAITPNE, whichever one you chose to code, and in low power mode. And as soon as the pin changes state, then it wakes up and starts running the code again. Right.
Gotcha.
So, like in the top pub of my my podcast clock, there's one switch on the front of it. If it's in one position, it starts counting up and showing you how much time has passed on the front of it. But if the switch is in the other position, it does a WAITPEQ after stopping all of the other cogs.
You've used this?
And turn the clock speed to a very slow clock speed, the slowest one. Ooh. So not only is it saving power by not running as fast, it also saves power by dropping itself into a WAITPEQ until that switch changes.
Right.
And then when it changes, it loads those cogs back up, changes the speed back to the right speed, and then starts counting up again.
That's very interesting. Gotcha.
But that's just, so you understand, it's waiting in a low power state until the condition that you specified occurs.
Right.
And obviously with the pin ones, it's waiting for the pins to be in the appropriate state. For the count one, it's waiting for the system counter to go that many counts.
Right.
So one of the things that, like, Whisker just said, where he's using it, he changes the clock rate and slows it down. If you were using wait count, that would affect how fast the system counter goes. So you generally don't change the clock speed when you're using wait count. But for WAITPNE and WAITPEQ, it's common to change the clock speed down because you want to save power. A lot of people make circuits that run off of batteries, and using the low clock frequency and using these wait commands, they get it to use as little power as possible while it's running.
Gotcha. Cool.
Flow
control.
So I know from talking with you that you've used at least a little bit of this stuff.
Have I?
In some of your LED blinking and heart example code. Because it's basically ifs and the case.
I've used cases, but not.
I think she's used case,
ifs.
And I think she has used repeat. I don't know if she's used if or not.
No, I have not.
Okay. Well, if is relatively simple for the simple form of it. Basically, they put an if keyword, and then you have a conditional expression that you specify right after the if keyword. And if that condition resolves to true, then it will do the stuff that's tabbed in underneath the if. And if it's false, it won't do the stuff that's tabbed in underneath the if. It'll skip over those and do whatever's after that.
Now, do you...
So one thing we should probably explain real quick, just because the listeners may or may not know this, but Spin is language uses the indentation to determine blocks of code.
Right.
So when you have an if statement, and the stuff that it executes is the stuff that's tabbed in underneath it. And like when you have a repeat, the stuff that it repeats is the stuff that's tabbed in underneath the repeat. If you have a line that's at the same tab indentation as the repeat, it won't be in the repeat block or
And
similar if block.
the neat thing about the prop tool is, which is like where you actually write your program in and compile and run it from.
Right.
That thing has these neat little lines that show you which block it's
Right.
part of. So
Yeah.
that's really useful.
It highlights with little gray lines and pointing at each of the commands and stuff. It's pretty handy.
Right.
So in your prop tool, if you type repeat, enter to drop to the next line, and hit tab, you'll see it create a little visual elbow so that you can see what this line that you're on now, where it's at organizationally in the looping structure or the logic structure.
Right. The same is true for the if and if not.
In case.
So just continuing with the if, so you have your condition, which is, some kind of comparison conditional Boolean expression where you might have like, say, if x equals 42, right?
And we were talking the other week about colon equals versus plus equals or just an equal sign. Here's another one. In an if statement, you're going to use the equal sign because you're actually comparing two values with each other.
Oh, so you have to do if x equals.
You'll notice that programmers tend to, when they're typing in chat rooms, for example, you might see them use two equal signs in a row because they're specifying that these two things are equal to one another, not that one is going to be assigned into the other.
Right.
Oh,
I
see.
Double equals is a comparison, and a single equals is an assignment, or colon equals in the case of spin is an assignment.
Sure.
So your expression is that. It could also be like you could use greater than. So if x is greater than 42, then if x is any value that is 43 or higher, it will do the statements that are tabbed in underneath the if.
There's also less than followed by greater than becomes if this is not equal to that. There's also things like if this is equal to or greater than, if this is equal to or less than.
Right. And there's a few other operations that are
and
or logical and logical or. It's
which
all
we've talked about.
Yeah, it's all Boolean operations, Boolean math.
Gotcha.
And those are your expressions there. And you can actually do some fairly complicated things. Like you could call a function from, you could say if and then the name of one of your pub functions. And that if that pub function returns a result that's true or false, it will cause it to do the resultant if statement.
So you would write it
or not.
You would write it if pub main equals 5, or if pub main equals.
Well, you wouldn't say pub.
True?
You would just say main, because when you say pub main, that's defining main as a pub function. When you actually want to call main in your code, you can just say main.
So if main equals true.
Yeah, because when a pub is done running, like if it doesn't have an infinite repeat loop in it or something, it can return a value. So when you run this pub off to go do something, it does some work with numbers, and it can return one of those numbers back to whoever the hell called it. And it could be called from an if statement. So you could go if the name of your pub and make a decision based on what that pub did, what numbers it found, what math it did, whatever, and then returned back to you.
Right. So the condition is anything that will result in a Boolean expression that is true or false, right? So true in the case in if, it will only do it if the condition ends up equaling true.
Yep.
As a result.
Then you've got things on after that, like else if.
Right.
So it'll be like if it's true here, else if it's false, then do this other thing, right?
Right.
Well, what's the
So
difference between ELSEIF versus ELSEIFNOT?
Well, else if would usually be used if you're talking about more than just true and false. If you're talking about if it's equal to 1, then do this. If it's equal to 2, then do this. If it's not equal to any of them, then do the else, right?
right. And we haven't actually covered, we were just about to cover if not.
Mm-hmm.
So if and if not are almost identical. It's just that if works when it's true and if not works when it's false.
Yeah,
Mm-hmm.
just inversions of one another.
Right.
And a lot
And
of the
so,
times when you would use else if, just use a case.
right.
Uh,
But you could have some situations where a case won't work. So like you might say if x is greater than 5, do this, else if x is less than 2, do that.
mm-hmm. I
Right?
see. I see. So you don't have to
And
include 2 to 5,
right.
right? Okay.
And
Interesting.
there's things that you might, there's much more complicated examples of that you could come up with. But this is, you're just learning, and those are
Yeah, let's not
you
make
know,
it too complex.
exactly. But you get the idea that that's what it's conditionally running the code that's tabbed in under it based on the expression up at the top.
Mm-hmm.
And if not is doing the same thing, except only if the expression results in false instead of resulting in true.
Right.
And that's also true for the else if not, as you could
Gotcha.
probably figure out.
Yep.
So
Interesting.
case is a little more
And this one I've
complex.
actually done work with. And
Right.
this one, I used it with my heart project again, where each different type of rhythm, I wanted it so that a person could scroll through them essentially, and with a momentary switch, just so click, rhythm 1, click rhythm 2, click rhythm 3. And
Right.
so for each of those rhythms, they were different cases. So instead of having like 14 different programs that I had to separately compile and run, I was able to reference each specific case
Right.
by the program reading the switch to see which number it was on.
Short version is she's got 3 cogs. One is watching the switch. The other 2 are running around in a circle with a case. And depending on how many times that button has been pushed in the main thing, it saves a different number into a global variable. And those case statements in each one of the cogs are reading that global variable to see what state the machine is in. And if it's in this state, do this thing. If it's in this state, do this other thing.
Mm-hmm.
Right. Right. So, just to cover a few little details, some people might be familiar with this as being a switch expression from other languages.
Yeah, or a select case is also
Right.
used.
There's a bunch of different other names for it. But basically what this is, it's sort of a shorthand way that ultimately the compiler can produce better results from, of doing a big long if, else if, else if, else if chain of code. And it's also usually easier to read. So you basically just have, you do your case and then you specify a variable usually. You might say case X. And then underneath that, you put in values that X could equal, followed by a colon, and then some statements that you want it to do when X equals that particular value. And then you can do another value below that lined up. Again, indentation is critical in all these. So each of the values that you say value colon, they call it a match expression in the manual.
Okay.
So each time you have one of your match expressions, which is the value that you're going to say X is equal to, that needs to be tabbed in one underneath the case line, obviously. And again, the prop tool visually helps you see this really well.
Right.
But all of the match expressions should be lined up one over each other so that they're indented the same amount and they'll all be part of the same case.
Right.
Yeah.
So
There's
what?
nice examples in the manual for these too.
Right. And then the one last detail is that they have what they call the other case. So there you can say other colon, and basically what it does is if it doesn't match any of the value or match expressions that you specified above, it'll do the other one.
The if equivalent else
I see.
case
Yeah.
is other. All right. That's all the time we have for this week. It looks like next week we'll be talking about the repeat loop and all of the little fun things you can do with that.
Very important.
Yeah.
Yes.
All right. Thank you guys for listening. You can find this podcast every Tuesday at firstspin.tv.
Yep.
Bye.
Bye.
Take care.